So we're going to talk about how logarithms work. Let's say you have ax equals to b, then you can rewrite it as log of ab equals to x. For example, you have 2 to the 3 equals to 8, then you can rewrite it as log of 2 base 2 of 8 will be equal to 3. So 3 is the power of 2, so that 2 to the 3 equals to 8. Now, if you want to evaluate a log term, that means you're going to get a value out of it. Let's look at the example log of 2, 8 equals to 3. So 3 is a value of the log term, log of 2, 8. In this, if you want to evaluate the log of 2, 8 to the 3, you can use the power rule, where you can move the power 3 down to the front of the log term, log 2, 8. And as a reminder that 8 is equals to 2 to the 3, then you can rewrite 8 as 2 to the 3, and then you can use the power rule again in order to move the 3 to the front, and you get 3 times 3 times log 2, 2, and we know log 2, 2 equals to 1, so the value of this log is 9. To the second example, in this case, again, you can use the power rule to move 5 to the front of log of 8, 2. And using the fact that 8 is 2 cubed, you can raise both sides by 1/3, the power of 1/3, to get 2 equals to 8 to the 1/3. Because the right side will be just 2 to the 1. And then you can rewrite 2 as 8 raised to 1/3. And then using the power rule again, you can move 1/3 down to the front, multiply by 5, multiply by log of 8, 8. And log of 8 is 1. So then the value of this log term is 5/3. Now to the next example, when you see a natural log term, which is ln. As a reminder, ln x equals to log of base e of x, where e is a natural number and it is about 2.71828. Is about 2.71828. All right. Again, we can use the power rule to move 6 to the front of the natural log term. And knowing that natural log of e should be equals to 1. So then the value of this log term is 6. Now we can discuss cases where there's an unknown variable like x, y, or z in a log term. In these cases, we cannot find a value, but we can simplify those terms. For example, in this log term, you can use a power rule in order to move the x to the front of log base 4 of 2. And again, we know that 4 equals to 2 squared. So then we can rewrite 2 as 4 raised to the 1/2. All right, and then we can rewrite, instead of 2, you use 4 raised to the 1/2. In this case, again, we can use a power rule to move 1/2 to the front, multiply by log 4, and log 4 is 1. So then the simplified form of this log is x over 2. To the next example, this is a case when you have a power term, but the exponents has a log of the same base of the power. Then you can use one of the properties in order to simplify 5 log a to get 20 plus x. And again, the rule is if you have a raised to log a of x, then it can be simplified as x. In the last example, we see a log without a base, and to remind you, log without a base, it means log of base 10. Again, we can use the power rule in order to move the power negative 5x, move the whole power negative 5x to the front, and multiply by log of 100. And we know that 100 equals to 10 squared. So then you can rewrite 100 by 10 squared. You can move the power 2 to the front and multiply it by log of 10. And log of 10 is just going to be 1 because it's log of 10. So it's just cancel the term log 10. Then the simplified versions of this log term should be negative 10 times x.